Hi, I'm Dr. Dave, founder of Stronger.coach. I wanted to talk to you for a few minutes about bioenergetics, or more simply put, how does the body generate energy? The energy your body uses is ATP, or adenosine triphosphate. It's an adenosine molecule attached to three phosphate atoms. A high energy bond holds them all together. When a cell needs energy for muscular contraction, nerve impulse propagation, transporting different molecules across cell membranes, or any other function, one of the phosphate atoms is synthesized or split off, leaving ATP, the phosphate atom, and energy. This process is called phosphorylation. There's a limited supply of ATP stored in the body, roughly 50 grams of ATP, or enough energy for several seconds of all out work. Because of this, the body is in a continuous process of breaking down food substrates into ATP. The easiest way for the body to produce more ATP is through phosphocreatine. Creatine is a naturally occurring compound found in beef and fish. When combined with a phospho group, it forms phosphocreatine and helps resynthesize ATP back into ADP. During phosphorylation, ATP is split into ADP and phosphate. Phosphocreatine puts the molecules back together so that it can be used to produce more energy. There's a very limited supply of phosphocreatine, and it can only be used for the first 8 to 12 seconds of exercise. Exercises that rely heavily on this system might be throwing a baseball, performing a high jump, or slam dunk. Many athletes will use oral supplements of creatine to enhance their performance. It is a perfectly safe and legal way to improve strength, lean body mass, and help recover more quickly. It will give you the ability to do 3 sets of 12 instead of 3 sets of 8. What happens if you need more than 12 seconds of energy? The easiest and quickest way for the body to break down carbohydrates is in a process called glycolysis. Carbohydrates are molecules containing 6 atoms of carbon held together with high energy bonds. There are 2 types of glycolysis, fast and slow. Fast glycolysis is also called anaerobic glycolysis because it occurs in the cytoplasm of the cell and does not require oxygen. During fast glycolysis, the 6 carbon carbohydrate molecule is cut in half to form 2 3-carbon pyruvate molecules, hydrogen, and 2 molecules of ATP, which can be used for work. The pyruvate can then recombine with hydrogen to form lactate and sent to the liver where it is converted back to glucose. If adequate oxygen is available, the pyruvate can enter the mitochondria of the cell and begin slow glycolysis. The key component in glycolysis is oxygen. If there is not enough oxygen available, hydrogen will build up, causing pain, and fast glycolysis will grind to a halt, which usually takes about 20 seconds. The acetyl coenzyme A molecule can then be further reduced in a process called oxidative phosphorylation, or the electron transport chain, to produce 34 additional ATP molecules. The net result of the breakdown of 1 molecule of carbohydrate is 2 ATP from fast glycolysis, 2 more from the Krebs cycle, and an additional 34 from oxidative phosphorylation, totaling 38 total ATP molecules being produced from 1 molecule of carbohydrate. The ATP-PC system provides energy for the first 10 to 12 seconds of exercise, fast glycolysis for another 20 seconds, and then slow glycolysis for up to 2 minutes. If you need energy longer than that, you'll have to rely on the breakdown of fat. The breakdown of fat is a multi-stage process called beta oxidation. Fat that we eat can be stored in the body in the form of triglycerides. A triglyceride molecule is comprised of a glycerol and 3 fatty acid chains of carbon atoms. The enzyme lipase splits off one of the fatty acid chains in a process called lipolysis. This free fatty acid can then be further broken down by cleaving off 2 carbon atoms, forming 1 acetyl coenzyme A molecule. This can enter the Krebs cycle to produce additional ATP. 1 molecule of triglyceride can yield up to 129 molecules of ATP. Although the yield is quite high, beta oxidation requires substantial amounts of oxygen and is a rather slow process. It takes twice as long as glycolysis. Beta oxidation is used for activities lasting longer than 2 minutes in duration and at a moderate intensity. Running a marathon, for example, would rely heavily on beta oxidation for energy production. This chart shows how the body uses energy for different durations of exercise. The above chart is a little misleading, though. You never rely solely on one energy system, it's always a mix. The chart represents the predominant method of energy production for each duration. For example, when running a marathon, the body is undergoing glycolysis as well as beta oxidation. So 50% of the energy produced is coming from carbohydrates and 50% from fats.